this online international workshop on artificial intelligence and research and showing your interest. Uh, I welcome you all to this workshop, and I just would like to mention some of the key point of this workshop. Why did we conceptualize this workshop? As you all know that technology is dominating in every area these days, and similarly the AI tools have also taken place and are helping in every domain, whether it is marketing, whether it's research writing, video creation, and many more. So we thought to have this artificial intelligence and research uh, for the discussion. And on this occasion, I'm very happy to let you all know that we have with us Professor Chris Cook from National Technological University, NTU, Singapore. And we also have Dr. Gurpreet Singh from Chandigarh, India. So, on behalf of all the participants, I request all the participants also to please join me to welcome you all to this online international workshop on artificial intelligence and research. Sir, we are really grateful to have you on the board. And I'm also welcoming Dr. Achala Munigal. She has just joined from Usmania University, Hyderabad. She is currently working in the capacity of associate professor as well as deputy librarian. So I request all the participants to please welcome Madam also to this international workshop on artificial
Hello,
intelligence and
everyone.
research.
Good evening,
So
everyone. Glad to be here. Thank you, Dr.
thank you,
Tripathi.
Madam. Thank you for sparing your valuable time to join this online session. Without wasting much of time, as I was talking about the AI tools and research, we all know that the AI tools are playing a big role these days, but we need to understand how and where to use and where not to use. So we will be talking in detail, and we will be having the session on 5 different dates from 6th of October to 10th of October. So before we begin the session, may I request you all to please join me to let us pray to Almighty God, Goddess Saraswati, and then we will begin the session. I request all to please join. Thank you all. Thank you joining me to just praying the Goddess Saraswati. And now we would start the session. Today we are going to have discussion on the topic which will be covered by Professor Chris Khu from NTU Singapore. Sir will be talking about the knowledge graph and visualization interfaces, potential contribution to librarians to artificial intelligence. So before I hand over the mic to Professor Chris Khu, I would like to just uh, let you all know about Sir. Professor Chris Khu is an associate professor at the Kim V School of Communication and Information, Nanyang Technological University, Singapore. He teaches courses in knowledge organization, representation, focusing on ontology, knowledge graph, graph database, and graph visualization, and data analytics, data mining, and social media analytics. He has obtained his PhD at Syracuse University and MSc in Library and Information Science at the University of Illinois. And also, he has graduated from Harvard University. He has also worked for several years as a science reference librarian and National University of Singapore libraries. It's a great honor, sir, for all of us to have you today in this online virtual session on artificial intelligence. We all once again welcome you, sir. And without wasting much of time, we would like to hear from you. And I request you to please throw lights on the different aspect of artificial intelligence and how it can be used, what are the different impacts, and many more. So over to you, sir.
Thank you very much, Dr. Tripathi, for the very warm welcome. And thank you, colleagues and librarians all over India, for coming to spend time with us and for your warm welcome. I feel like I'm a visitor in India, even though we are having this virtual meeting. Let me share my screen and then I can begin.
Sure, sir.
Okay, I'm going to share my slides. Okay, Dr. Tripathi, you can see my slides.
Yes, sir. It is very much visible.
Okay, thank you. All right, let me begin. So the title of my talk is Knowledge Graph Applications and Visualization Interfaces. This is my pandemic project. So I've been working on this for 3 years during the pandemic. And because this workshop is related to AI, I'm going to link it, yeah, with AI. In fact, I'm going to suggests that knowledge graph is one main type of AI that is very close to the heart of librarians, and that this is where librarians can contribute to AI. I think we can all agree that libraries, librarians, and library schools, we are all at the crossroads. We have to develop new directions in library science and in library services. Because a lot of our roles, the traditional librarian roles and library roles are being taken over by the World Wide Web, by Google, and now we have ChatGPT and generative AI. So I'd like to begin by suggesting that we need to change the mission, our mission of libraries and librarians. And actually, in every talk that I give, I suggest this. I suggest that the purpose of libraries and librarians is not enough, not just to provide access to information, and to provide relevant information. Of course, we must do this, but Google also does this very well. But we must also put more emphasis on supporting users to link things together, to link data, ideas, people, tools, to integrate information, to synthesize, and to learn, create new knowledge, and use the information to make wise decisions. So, learning, creating, and using information, of course, that um, presupposes that information is linked together. So, linking, integrating, and synthesizing. And I think that relates very well to knowledge graphs and ontology. We all know that generative AI is the hot topic of the day, right? Chat GPT. So everybody, I think in every field, they are exploring and playing with generative AI and Chat GPT to see how we can use it in our profession and in our work, right? So librarians are doing the same. Many of my librarian colleagues are familiarizing themselves with ChatGPT and other kinds of generative AI and thinking about how we can incorporate it in our work. Yeah. But generative AI is not our core area, right? It's it's a computer science and AI area. So we need to be very creative to link or to use generative AI as a tool. It's just a tool for us because this is not our main area. But we need to link it to our core strengths. So I think the core strengths of librarians is a knowledge organization, that's very close to a librarian's heart. In India, I know that colon classification is very big, very strong. So that's our core area. So we need to link our core areas with AI. We use AI as a tool to help us to maybe reinvent or invent a new direction in our core areas. Other core areas are reference and user services, collection development, information literacy, scholarly communication, digital libraries, research data management. You all know that these are the areas of our strength. So now we want to see how we can develop a new direction, making use of AI tools. For tonight, I want to focus on knowledge organization, which is something that's close to my heart. I think it's a very important is a pillar of LIS. So now I want to see how we can change the direction of our knowledge organization to make use or to relate it more to AI. So I would suggest that one important direction for knowledge organization is knowledge graph. Yeah. So I see knowledge graph as a new direction in knowledge organization. So we should we shouldn't abandon knowledge organization because it's important to us, but we need to put more emphasis now, develop a new direction in knowledge graph or ontology. So knowledge graph and ontology are very similar. They are used interchangeably. So ontology is an earlier term. Now, I think it's more popular to call it knowledge graph. So what's the difference between knowledge organization and knowledge graph? Knowledge organization traditionally focuses on organizing documents and books and describing it. So that's cataloging, right? And metadata, we describe documents and books. I think we have to now put more emphasis on not on the books and the documents, but in the content. So I say that knowledge graph represents the information content and the knowledge content of the documents. Knowledge graph is very close to AI, but it's one type of AI. It's not GPT, Chat GPT. It's a different kind of AI. It is a branch of AI that's called symbolic AI. And it is also called explainable AI. That means you can understand it. For Chat GPT, you don't know what's going on inside the neural network. But I suggest that knowledge graph is not just, it's traditionally developed for intelligent applications of AI, but we can also use it to help users to browse, to learn, and to analyze and do research. So what is knowledge graph? This is my own definition. It's very informal, but I think it captures it's more user-friendly. So knowledge graph, I would define it as a social network. Yeah, it's like, but instead of social network of persons, this is a social network of ideas, concepts, digital objects, and resources. So it's made of nodes connected by links, sometimes called edges. So we have nodes and links or relations. So the nodes would represent concepts or entities. More generally, we call it resources. And each node can have metadata, can have a set of properties or attributes. And the nodes are linked together, right, using these arrows or links. And the links represent relation types. And the links can also have its own properties. And of course, we must not forget the class hierarchies and classification system and taxonomy. So that's incorporated in a knowledge graph. Some more background about knowledge graph. Knowledge graph is actually used interchangeably with ontology, with RDF triples, semantic web, linked data, knowledge representation. So it's used, synonymously with these terms. But I think knowledge graph has more emphasis on the graph, right? Because it has the word graph in it. So it's more emphasis on the graph or network representation. By graph, I don't mean the charts. No, it's not a bar chart or scatter plot. Graph here means graph theory, which means network, network representation. Actually, knowledge graph and ontology and knowledge representation, this has been researched for, I would say, more than 50 years. But after 50 years of research and development, I'm sad to say that there's no compelling application. There's no killer app, that users are excited about. So there's no killer app for ontology and knowledge graph that is publicly available on the web. I remember that 20 years ago, when I started to teach ontology, I told students that within 5 years, ontology is going to be hot area, and they will all be able to get a good job in the area of ontology. Now, 20 years later, I'm saying the same thing to my students. I'm telling them that in 5 years' time, ChatGPT will be not so exciting anymore, and knowledge graph will be the in thing. So what has happened? Something has gone wrong. So currently, data-driven AI like GPT is the dominant AI paradigm. But some researchers believe, including myself, believe that data-driven AI needs to complement with symbolic AI like ontologies. We believe that data-driven AI and symbolic AI are complementary. We need them both. So in future, I think in the next few years, people will be looking to see how to combine or complement, use both together to come up with even better and more usable solutions. So I'm persuading you to change direction from knowledge organization to like put more focus on knowledge graph. But I need to caution you that we need to develop applications quickly. I think that in the past, we take a long time to develop any kind of system. Our projects take many years. Okay, I think that if I would say that if a project takes 2 or 3 years, it's failed. We need to be able to quickly develop new applications within a few months. I would say 3 months a prototype has to come out. And within 6 months, your at least first version has to go out on the web. Now, I think that it is now possible to do that because um, I tell everyone that this is actually the beginning of the golden age of IT. IT is now quite mature. We are now able to do things uh, that we weren't able to do 10 or 20 years ago. In fact, I told my PhD supervisor that I'm going to go back to my PhD research and implement it now, which I couldn't do many years ago. So it's now possible to develop new web applications and services quickly with a small, talented team of librarians. You don't even need IT professionals. You just need some talented librarians with some talent for coding, and you can already develop new and exciting applications. So in this talk, I'm going to show some knowledge graph applications that I've developed, and I'm continuing to develop them, to evolve them, to improve them. And I'm going to show you the insights, the architecture, the innards, the code, to give you some idea how they are put together. So the rest of my talk will have 3 parts. First, I'm going to demo 4 knowledge graph applications that I've developed. And then I'm going to show you the different layers of technology that I use. And I'm going to actually show you the insights of the technology, maybe things you have never seen before. That IT, people will hide from you, say that it's too difficult for you. No, it's not so difficult. You can now use and develop these technologies. Then I'm going to give you some preliminary results of a user study that I'm doing. I'm studying the user behavior of users using these knowledge graphs. Okay, so I'm going to show you 4, I have more actually, 4 knowledge graph applications. I'll just briefly mention them now. Zubir site, personal archive, Singapore Pioneers, social network, Asian traditional medicine, and scientific knowledge graphs. Okay, the first one, this is my very first knowledge graph project. Zubir Said was the composer of the Singapore national anthem. He was a composer of song, he was a songwriter, and he wrote music for the film industry in Singapore during the golden age of the film industry in Singapore. That was before Hollywood, and Bollywood. So he was a movie music person. So his family donated his personal archive, his manuscripts, his documents, his audiovisual, recordings and so on, to one of the music schools in Singapore called the Nanyang Academy of Fine Arts. So it is a premier art school in Singapore. So I'm using the knowledge graph like a kind of digital library, or a digital heritage portal. Okay, let me go on first. And in this knowledge graph system, I use the knowledge graph as a knowledge organization tool. I use it to organize the resources in this digital library, and as metadata, and also as a visualization interface. And this is to describe and link the digital resources in the archive as well as to the web using a network, because knowledge graph has a network structure. And I also have some graph visualization, which will give you like a mind map to support browsing and learning. But also, I hope that knowledge graph can help users to synthesize a narrative, that means a story about, or an essay on a topic. Okay, so this is just a picture of knowledge graph, but now I'm going to give you the demo. Right? So I'm going to now switch over to my web browser. Okay, and here. Okay, so this is a real life, website. You can see here it says zubirsite.sg. I'm going to play a 4-minute video tour, then I get a break. Yeah. This is a short demo of the Zubir site knowledge graph interface. Select a song in the pull-down menu. While the graph is still being displayed, you may adjust layout and help to disentangle the graph by pulling on nodes in the graph. When the graph has stopped moving, you may apply other graph layouts. For example, tree layout, concentric layout, force course, spread out, or use the default force collar, which adjusts the graph incrementally. Click on nodes in the graph to display metadata associated with the node. The info box may be repositioned by dragging it, or you may pin the box down by clicking on the pin, after which you may copy and paste text in the box. Click on hyperlinks in the box to display related resources. To dismiss the info box, double-click on it. To expand a node with the related nodes, right-click on it or double-click on the node. For example, to display related information to this node on Fun Yu Tian, right-click on it. Clear the canvas to display other kinds of networks. Explore the buttons on the left panel to display other kinds of networks. For example, a social network centered on Zubir site. If too many nodes are displayed in the graph, you may apply a filter using the toolbox on the right. Select the node types to retain in the graph. You may also apply a filter to the types of links or types of relations. This is listed below at the bottom of this toolbox. After applying a filter, you can apply a graph layout to adjust the layout. You may zoom in and zoom out of the graph by using the scroll button on the mouse. You can also open the graph to full screen mode. Have fun exploring the knowledge graph of Zubir's site. Okay, so that was a quick video tour of the visualization interface. So that's called a graph visualization. I want to point out just two things about this interface. First, this is actually a kind of information retrieval system. So behind this interface, there is a database, and it's called a graph database. So the links here, or the buttons here, are actually retrieving data from the database. But instead of showing the data as a list, like in the search engine, it shows you as nodes. So each node is a record in the database, but also the links between them. And if I click on more buttons, you can see that it keeps adding on to the display. So this is a bit different from a usual information retrieval system. Uh, on the other hand, the filter on the right is actually filtering the results, the records that are on the display on the graph. So I'm getting all sorts of emails right at this time of the night. Okay, so this is to retrieve information from the database. So in other words, the whole knowledge graph is not on the interface. What you see is only a subset. It's only a few records that's retrieved from the database. And this is what many users don't understand, because their familiarity with a graph is that everything is there. No, it's not. You're only seeing a small subset of the data, whereas this filter is retrieving. This is to filter what is already on the graph. Okay? The second thing I want to point out is, let me select Majula Singapura. And by the way, that's the Singapore national anthem. You can see that there's Majula Singapura. And you notice here that it says the type is musical work, right? This is a work. Yeah. And then if I trace the score, and if I click on the score, you see that it says realization. Okay. And then the realization is linked to this. Okay. And this one is a score. Okay. This score is actually an expression. And then when I trace this item to this, then you get an item. So in other words, this is based on FRBR, okay, that most librarians are familiar with. This is based on the music ontology, which is modeled using FRBR. Yeah. But you notice that even though I have the work and I have the expression, I don't have manifestation because I found that if you have too many links, the users get impatient. So I have to simplify it. So one advice I give you is, when you're developing a knowledge graph for users to interact with you, you cannot use the library standards. You need to simplify. In fact, users often want to see the hyperlinks immediately here. They click on this modular singer or song, and they immediately want to have hyperlink. I say, no, because for a particular song, there may be different expressions. There may be different scores or different arrangements. So you need to go to this link, and then there may be different publications. So manifestation, right? Okay, that's too much. So that's why. And also because this is an archive, it's not focusing on books or published. So I skip the manifestation part and immediately link to the item. These items, you see that they're hyperlinks, some of which goes to the National Archives. So I'm trying to link the resources in our archive with the World Wide Web resources, and also with our Singapore National Archive. So for example, let me see. Okay, by the way, if I double click on this, then I get, see, related links. By the way, this is type, this is a class, right? Class. So you can see that there is a taxonomy behind this knowledge graph. Let me see if I can find some. Okay, no, I'm trying to find a link to our National Archives, but I'm having some problem. Okay, maybe this one. Okay, see, so this links to the National Archive. Okay, it's just unfortunately there's no digital video. Quite often there's a digital video. This one is still, you still hard copy. You still have to go to the audio tape in the archives. Yeah. Okay, let me move on now to the Singapore Pioneers Project. Okay, so this is a collaboration with our National Library to create a social network of Singapore pioneers. The important politicians, businessmen in the pre-war or post-war Singapore. So this is still, I would consider this a prototype, okay, because we only have 20, we selected 20 out of 400 biographies to model the ontology or the knowledge graph. Yeah. And let's say Paul Abisheganaden was a famous musician here in Singapore. Okay, so here you can see that these are the relations, so we have a relation hierarchy. What are the relations? So we had to make a list of relations that we will model in our knowledge graph. Okay, and we can put other people. Let's say go with the Pillai. You can see that it's, yeah, they all appear to see whether there are some links or not. But I see that there are no links between Abhishekanadan and Govindasamy Pillai. Okay, now I find some links, right? So I see here that Juma Boy is a businessman, I think, Indian, arrived in 1916. He was a grand old man of Scots. Yeah, so that was an important mall, shopping center. So he has business in property, and similarly, Govinda Pillai has a shared, interest in property, and so they probably know each other, and they have a, oh, okay, they are friends, and they are both justices of the peace. Yeah. So I'm going to, next year, I'm going to use ChatGPT and generative AI to extract information from 400 biographies to populate this knowledge graph. So this knowledge graph is hand created to create the structure. Okay? And then after that, we need to combine it with uh, another kind of AI, information extraction, text mining, and GPT technology to flesh it out to get extract information from 400 biographies. And then after that, we are going to do some data mining on it to look for maybe communities or relationships, and so on. Okay, so this is something we are still working on. Maybe I can show you one thing. So for example, one thing you can do with a knowledge graph is to trace the path, relationship. So if I'm looking for, let's say, two persons, let's say Lee, okay, and let me select Lee Kip Lee, and then another Lee. There are a lot of Lees in Singapore, including Lee Kuan Yew. And then let's say Dick Lee. Dick Lee is a famous musician. So I say find path, find what is the relationship between them. Then I see that Dick Lee is a nephew of Lee Kip Lin, and then who is a brother of Lee Kip Lee. So we can trace path in a network between two persons. Okay, so this is just one type of analysis, and we are looking at other kinds of analysis. Right, let me go on to the third project, which I think is the most ambitious. This is a collaboration with a history professor who has a background in traditional Chinese medicine. Okay? So he is a traditional Chinese medicine practitioner. So he is trying to create a database of traditional medicine and herbs in the Chinese tradition, but also to link it with herbal medicines in Malay, in Indonesia, okay, and also in Southeast Asia. So let me demo a bit. Okay, I see here that I tried this interface earlier. Root, let's say I'm looking for a root, because there are many medicines made from roots. And then these are various kinds of roots. let me just choose one randomly, right? What is this? Phloem of root. I have no idea what that is. Okay. And then I see that there are a few Chinese drugs or herbs made from that root. Okay? So you can see that this is a record. Yeah, Wu Zhu Yu Gen. Okay. And in different languages. So this is in Hanyu Pinyin, and then this is in um, simplified Chinese, and then it's supposed to be in traditional Chinese. And you can see the links to external databases. So okay, so this is the herb. Yeah, Wuzhu. Okay, yeah. And then my colleague is trying to find the scientific name. So this is the scientific name. Okay, and then also links to various databases, including the UK Botanic Gardens and so on. And then the regions or the cities where this herb was associated with, maybe this is where it was grown or traded and so on. And you can see that when it was, this is in -2 BC 200 to AD 200, late Qin to late Han dynasty, and then the regions here. Hmm? And you can see that there's a graph here. Yeah. So this graph, um, you know, yeah, shows you the herb or the drug linked to various related information. This is the scientific name, and then the regions, and so on. So if I let's say double click on this scientific name, then I can find out what other drugs have this scientific name. Let me see. Okay, so I can see that for this scientific name, there are two other drugs, this one and this one. So if I click on this, you can see that, okay, this is, yeah, very similar name, right? Yeah. Okay. So this interface is a bit different because there's more text, it's not just the graph. So if I, let's say, go back to the original one, you can see that the information that's in this graph is also shown as tabs. So this is the scientific name, plant name, region, and so on, provenance. And if there are alternate names, it will also show here. Okay, so this is, and this interface has more a balance of the graph visualization, and then the text as tabs here. And in this tab, I can also say focus in the main panel to get the, to focus on the main panel. And this is a book, old book, right? From mine, 2000, 200 BC to 200 AD. And these are the drugs that's listed in the book. Yeah. Now, behind this knowledge graph is the graph database. Yeah, you can see that the graph database stores all this related information. And actually, when you see these hyperlinks, these are all related information that would be shown as separate nodes, but they are like linked together. They're displayed together. Okay, let me show you another last one. Okay, this is a project that seeks to extract research results from journal articles and to model it as a knowledge graph. Okay, so this is still a prototype. Okay, for example, there's this social science article paper, drawing from cumulative inequality theory. We examine the relationship between childhood disadvantage and health problems and adulthood. So what we are trying to do here is to model what kind of research they are doing, what is the research objective, what is the research results, research gap, and to see how they are linked together. So we call this the argument structure. We see how the argument is built up. Okay? And how the author supports the research result, okay, through the evidence that's provided here. And our focus is on causal relation, what causes what. Okay? So for example, here, if I right click on this, it says economic deprivation and problems in early life influences mental health and status attainment when you're old. So this is a general statement. And then you can see, okay, what does the literature review say? It says early experiences has links to adult health problems. Okay? And then research gap, early experiences threaten health in later life. Okay, and then research objective. Yeah, okay, this one is more complex. You can see that there's also things like what is the data source. Okay, so they are going to do a longitudinal, their data is a longitudinal data from national sample. Okay, what framework are they using? Here, yeah. And then we look at the research results. Then it gets more complex. They mention some mediator variables. So we are modeling causal information in a research paper, tracing it from the general statement to the research gap, okay, to the research result. And we can see also how these concepts are linked together. So if I click on, let's say, mental health, okay, you can see that it's health, okay, adult health problems, okay. So we can, so this is a taxonomy. So we can see how the concepts in the different statements are linked together, okay. Health in later life, and this is linked to adult health situation to health. You know, so we can see how the different statements are linked together. Okay, a related visualization is this one, where okay, let's say we have a research result. Okay, so we see here the research result, and we want to know what new concepts are added by the different statements. So if I click on research gap, okay, you can see that these are new concepts. Early experiences threaten health in later life. And then if I, let's say, okay, research objective. Yeah, so you can see how the different statements flesh out the research results. You know. And if I click on this, okay, then you can see that this is a taxonomy. And then childhood, right? So let me see. Is there anything about childhood? Okay, never mind. Multiple health. Okay, so it's now showing the how the different concepts are linked together using the taxonomy. Okay. Okay, so actually I'm showing you this to show you that in this visualization I can specify the positions of the different nodes. You can see that I carefully program it to display it like this so that it's easier, you know, to read for users to read. Whereas for this one, you can see that this is, sorry, this is the layout is using an algorithm. See, algorithm, right? An algorithm. So it uses some algorithm to give you a nice layout. Whereas this layout is like a range, you know, I actually had to program the positions of these things, you know. I can also unlock this. So if I unlock this, okay, then I can move them around and then I can, yeah, I can also apply an algorithm. You can see that now it is moving, right? It's not locked in place. Yeah. So this is to show you the power of this graph visualization. Okay, let's see what time is it now. It's already, wow, 11:19. Okay, I think I have about 10 more minutes, perhaps. Okay. Maybe Dr. Tripathi will be kind enough to give me a little bit extra time. Okay, let me go on now.
Yes, sir, please carry on. Sir, please
Okay,
continue.
okay. So when I created this knowledge graph, I treated it as an ontology. So I used the standard ontology methods. You know, so I developed it initially as an ontology based on OWL2 descriptive language, and I use an ontology editor called TopBrate Composer. I like this software. So I teach this in my knowledge organization class. You know, I spent half a semester teaching ontology and using TopBrate Composer ontology software. The students hate it, you know. They find ontology so difficult, you know. So in this project, uh, I adopted many existing ontologies, especially music ontology. You may be familiar with schema.org, FRBR, CRM, you know. So I look, so this is the standard way of developing an ontology, to look for existing ontologies and you mix and match, right? Yeah. Okay, I found that it is too difficult. Yeah, so, and the result is too complex for browsing. Yeah. So, I'm going to make a controversial statement. I'm going to say that OWL, and RDF, which we librarians now love, has failed. Because after 20 years, there are no well-known applications that's accessible on the World Wide Web, and it's too difficult. It's too complex. There are too many specifications, too many layers, and to implement an ontology application on web requires such complicated software and so many layers. So I now avoid. I would advise that if you're developing a knowledge graph application, you don't need to follow the standards so strictly. I would advise a lightweight, approach to developing a knowledge graph application, and I'm going to show you how I do it. And I'm going to show you that librarians can do it. Whereas if you are developing an ontology application, it's too difficult. You need a lot of technology and it takes a long time to develop. And then the result is too complicated for users to use. So now I'm going to show you the technologies I use in my knowledge graph application. Okay, this is the architecture of my knowledge graph application. You have seen the web page that is used as a user interface. It makes use of HTML, cascading, structure, and JavaScript. So the highlighted one, the important one is JavaScript. Okay? And the visualizer, there are many visualization packages. I would recommend this one. This is cytoscape.js. It is being maintained and developed by a team at MIT, and it's free. and you can see that it works well. Yeah. And for the database, I'm using a well-known graph database called Neo4j. And this Neo4j is available as a cloud database service, and the company calls this Aura DB. So this is what I'm using. I advise this method, this way of developing the database and implementing the database, because it's fast, it's easy. You don't need to buy a server and then install Neo4j on the server. You just go to the cloud and just create your database right away. And by the way, this Aura DB cloud service is on Google Cloud. And okay, they charge by by the minute and so on. So okay, it's not that cheap. Okay, it's about, for a small database, it would be about I think about 80 US dollars a month. But it's still cheaper than buying a server and hiring IT people to develop it. Okay, now there is this middle server that's called, I call this a middleware. Okay, and this middleware is implemented as a so-called web API. So API means application programming interface. Don't worry, I will show it to you. It's not so difficult. On this API is on a server, yeah, but again, it's on the cloud, so you don't have to buy your own machine. So I use a Google App Engine, and I pay about 50 US dollars a month for running this web API on Google App Engine. And this makes use of something called Node.js. Node.js is just a platform or environment for running JavaScript. So over here we have JavaScript running on the web browser, and over here we have JavaScript but running on the server. And this JavaScript acts as a middleman, or middle person, middleware between your web browser and the database. So in other words, from your web browser, you don't access the database directly. You go through this middle layer. Okay, now why this middle layer? Actually, technically, you don't really need the middle layer. You can, from a web browser, directly access the database. But there are three reasons why you need this middle layer. One is that when you access the database, you need to provide user ID and password. So you don't want the user to be able to see the user ID and password. So you hide it here. Okay? The second reason is you may want to hide some of your intellectual property. So if you do some AI stuff, intelligent processing, you may want to hide it here so that it doesn't go to the user's browser. Where because anything that goes to a user's browser, browser can steal it, can copy it, can download it. So you want to hide some of your code inside here. Hmm? The third reason for using this middle layer, and that's the most important reason, is that when you access this API, this is called a web API because it's like a website. Hmm? So it makes use of the World Wide Web protocol. Whereas if you access the database directly, you're now using a special protocol called Neo4j protocol, which many firewalls will block. So if you are operating within the intranet in your university, maybe the firewall for your intranet will block you from accessing the database directly because it uses a protocol that it doesn't understand. So the intranet is suspicious. So that's the most important reason. But when I am actually developing the application, I would develop it by connecting directly to the database because it's easier, simpler. But once I want to launch it, then I will put some of the code in here, okay, so that then everybody can access it. Because as I said, if I connect directly to the database, some users will not be able to access the database because of their firewall. Okay. All right, now let me show you the code for some of this um, you know systems. Okay, so the web page you've already seen how it works. It makes use of JavaScript and Cytoscape JS. Okay, let me show you where you can get Cytoscape JS. Okay, this is the okay here. See, you say Cytoscape JS. Okay. There are two versions of Cytoscape. One is a desktop version, okay, but the one I'm using is the version that can run inside the web browser. So this is, and so you can embed it in a web page as you see me doing it. All the programming language, the coding language is all on this page. Everything you need to know is here. Okay? So, for example, let me show you part of the code. Okay, this is the Cytoscape style sheet. This is where I specify what the nodes look like. So here I say that the node, okay, the label, I'm going to use the data from the label field. Label field is from ontology, right? And then I specify the icon. What kind of icon? Okay, it's an ellipse. That's a shape. And then how big is the icon? Okay, the height is 30 pixels. And then the width is somewhere down here. Okay? And the color is this color. And then the border, that means the edge. What is the color for the edge? And then I have the style sheet for the edge, that means the links. So, okay, again, you have things like color, line color, and so on. What kind of arrow you're going to use, and so on. And lower down, as example, I specify a special icon for the musical work. So I specify an octagon. So there are all sorts of shapes that is in the vocabulary that you can use. But you notice for Zubir site, I use an icon. Right? So here I specify where to get the icon. So the background image is obtained from this icon. And all my icons I get from istock.com because it has a rich collection of icons. Okay, so that is, I will show you more of this JavaScript later if there's time. Okay. All right, what else shall I show you? Okay, let me go to the database, the Neo4j database on Aura DB. Okay, I have it here. Okay, so this is the interface to the database. This is the interface that that the developers use, that the librarians can use, because you have full access to the database. The users don't see this database. So this interface connects directly to the Neo4j database. You will see here at the left that these are all the classes, or sometimes called the types, the data types. So you can see here work, see, musical work, expression, manifestation. Where's item? Okay, item. Okay, so this is from FRBR, right? So these are classes. So if I click on, let's say, musical work, okay, you can see that it automatically creates a query. Okay, so this is the Neo4j query language. So you can see that these are some musical works. Okay, this is Majula Singapura, which is the national anthem. Yeah. And this interface is for developers, right? So it has some simple interactive functions. So if I click here to get related links, okay, so you can see that it says, if I open this up, you can see it says Majula Singapura. Mention, okay, mention, that means there must be some article or newspaper, mentions this Majula Singapura, but I'm trying to find you the FRBR. Okay. See, it says here realization. Realization. Realization means the expression. You will link to the expression. So this is the expression. You see, musical expression. You can see that I'm a true librarian. I'm using FRBR. And then it links to, then I skip the manifestation. I go immediately to the item. Yeah. Okay, so this is the Neo4j, the database. You can see here the relations. What relations? You can have expression. Okay, where's okay, never mind. You have things like, okay, author. There should be creator, right? Because that's a doubling call. Do I use creator? No, I don't use creator. Okay. Contributor. Oh yeah, I have creator. Okay, let's say creator. Yeah, so you can see that Zubir is a creator for a letter here, a book, and so on. Yeah. Okay, and so there is a rich query language for this Neo4j, which I teach my students. So the queries go here to retrieve this. So, but this is an interface for developers to use to query. But if you are developing an application, the application has to submit this query, okay, to the database to retrieve the data. And as I said, when you submit a query, the user, when it submits a query to the database, it goes through this middle layer. Okay? So let me show you what kind of code appears in this middle layer. Okay, this is the one of the middle layer for Sync Pioneers. You can see here, this is the Neo4j query. Yeah, it says query inter-ethnic. Okay, I'm looking for inter-ethnic relationships. Maybe this one is easier. So I say query 0. Okay, this one is just to look for related. See, there's only one link. There's one entity 1, entity 2, and then looking for a relationship. Okay. And by the way, notice that in this query, there is a parameter. So parameter is what the users enter. This is a variable, a parameter. Okay, and to plug into this query. So you can see that in the middle layer, the queries are stored here. These are all the queries I use. All the users can provide is the parameters. So for example here, this is a parameter. Here I allow 2 parameters. So here I'm let me see if I can find one with 2 parameters. Okay, maybe let me say something about this one. This one is to look for a person, link to another person, okay? But using a link that ranges from 1 to 2. So it's looking for 1 link and 2 links, So you're looking for 2 persons that are not directly connected. Yeah, okay, this one doesn't have parameters. Okay, so this runs in the middle layer. So that's hidden away from the user. Okay, what else can I show you? Mm. Right. So now, since there's a middle layer, the user is going to send a query to the middle layer, and the middle layer will then submit the Neo4j query to the database. Okay, and I told you that this is called a web API. Right, sorry. Oh, I got too excited, right? Okay, so there's a web, okay, web API. Okay, let me show you what this API means. Yeah, this is a web API. A web API is actually a website. It's just like a website, except that it doesn't give you a nice web page. It only gives you data. So let me show you the script that is inside the web browser and how it accesses the web API. Okay, this is a script in the, oh, I think I got it. I opened it and yeah, okay. So this is submitting a query to the web API. You can see that in the JavaScript is very easy. So you say fetch, fetch, and then it provides the URL for the API. So this shows you that the API is just a website. But you don't get a HTML document. What you do is you submit the what this you can call this the API, Zubir site API, and then a few parameters. So in this case, there's one parameter, 3, and then after that, a blank uh, parameter. So actually, this is like a URL. You can copy this and put it in a web browser. I'm going to pull up a new tab. You see? So I copy this. Okay, let me remove the quotation mark. Okay? chriscool.net ZS, which is Zubir site, and then 2 parameters, 3 and then a blank. Okay, so we can see that this is actually a website, but it doesn't give you a nice web page. It gives you this data. Right? Yeah. And when you look at this, you can tell, if you look more closely, you'll see that it has label is musical work. Okay? And then the properties are all the attributes, the metadata. So it says the comment is blank. The label is Sayang di Sayang, which is the name of a song. And then I have a field called property called collection. This is the ID number and the type. See, there's a type is musical work. Yeah, so you can see that the API just gives you the data. And so the web page has to use this data to plot the graph, and to display it to the user. But this is the actual data. You can see that this is a real, right? This is real time. Yeah. And I have a few more examples here. Okay, this is the same. Okay, so for example, this one is ZS0. 0 means query number. Okay, and then I indicate Majula Singapore. So I'm looking for all the links that are linked to the national anthem. And if you look closely, you can, I think, figure out the structure of this. So I say here, see again, you see here properties. So these are all the metadata. The comment is blank, the label is modular, collection is Zubir site, and the type is musical work. So even human beings can understand this, right? Yeah. Now, this data structure is called JSON or JSON data structure. Okay, and it is something that actually you can understand. It's not that difficult. But the web page has to take this and then extract all the information to display it in the graph like this, yeah, like this, So this is all this data is taken from this API. Now this API is implemented on Google Cloud. So let me show you Google Cloud. Very easy. You just type in cloud Google and you get to Google Cloud. And so I have implemented this. You can see this is App Engine. This is API. Yeah, so this shows me the activity that's on my API, So it shows me if I refresh this. Okay. Let's see how much activity I have in the last, let's say, 2 days, last 7 days. Okay, you can see that I've been working hard. I've been doing some work to prepare for this presentation. I don't know what happened here. Yeah. And these are the queries that have been submitted. Yeah, remember just now I typed in ZS3 dash. Yeah, so all the queries that are submitted to the API are listed here, but this is for the last 24 hours. So since I was using this as an example, you can see that I've been, there are like 13 times, yeah, example. SP is a Singapore pioneer. So just now I was showing you that. So every time I just load, it will access this, and that has been 33 times. Okay, then we have ZS is Zubir site, 0 is query number, and then this is a song, Perigi Biru Zubir site arrangement. Okay, now I was looking at a photograph, So all the queries are listed here in this dashboard. Okay, so this is the interface to manage the API on Google Cloud. Okay, I think there's only enough time for me to show you this but I hope that I have convinced you that it's doable. You can have a small team to implement all this. All right. Okay, maybe you think I can have another 10 minutes, Dr. Tripathi?
Yes, sir.
Okay, all right.
Please, sir.
Okay,
Continue, sir.
then I will finish. So this is the next part is to show you preliminary results of a user study. So I want to see how users can make use of this interface. And I would like to suggest that this can also be a new direction in information research, information behavior research, user information behavior or information or user search behavior, but not on the typical information retrieval system, but on the knowledge graph. Okay. So I want to also study user learning, information use in writing an essay using this knowledge graph. Okay. So the objectives of the user study is to find out whether novice users, because all the users in my knowledge graph are novice, right? Nobody is expert in this kind of interface. Whether they can read and interpret the graph visualization to identify desired relational information, and whether users can synthesize the information to write an essay, and also what issues they have with the interface. So this user study has two parts. I'm just going to talk about the first part, which is whether users can find relational facts on the interface. Part two is on whether they can synthesize an essay. So I assign the users, let me skip over this, or maybe some theoretical assumptions. I think they will be useful for us to understand how users are interacting with the interface. My assumption is that users are familiar with the traditional information retrieval system and search engines, but these traditional information retrieval systems are record-centric. They display one record at a time. They don't show relations, right? Except maybe the subject headings, keywords field. When you click on it, maybe they show you other records with that keyword. But basically, they are one record at a time. So users have no experience with this links, this relational information. And so the user's mental model, the way they imagine the retrieval system is working, is based on traditional information retrieval systems. So when I analyze the user behavior, I'm trying to see whether in what ways the user's mental model is inaccurate or defective or wrong, okay, when it comes to a knowledge graph. Okay? So I gave them 6 questions or 6 tasks. The first task is to find 2 songs that Zubir site wrote for movies. Okay, so find 2 songs that are composed for movies. And I gave the subjects a tip. I say on the left panel, click on Browse by Song to select a song. So, okay, what I expect the users to do is to click on the song. Let's say this one. Okay, so this is the song. Yeah. And this is one arrangement, and this is another arrangement. And you can see that this arrangement here is linked to this. I think from this icon, you can make out that it's a movie, right? Okay, so uh, by tracing this link to this arrangement and to this movie, okay, users should be able to tell that, okay, this song is somehow related to this movie, and even says perform in this movie. Okay? So this is one way to find the answer, that this song was sung in this movie. In addition, if you click on this, and this, you look at the metadata, it says the film contains the song Nasib Malang, composed by Zubir. So this is the second way in which users can find out that this Nasib Malang is sung in this song. Okay, yeah. Okay, one problem users have with this is when they are looking at this, even though it's a tip, the users don't understand in why by selecting a song, they can find out whether the song is in a movie or not. Okay, and I think it's because users think that this is a record, based on their mental model of search engines. If you click on this, you should get the song. Okay, but in a knowledge graph, when you get a song, you also get links to related information, and I think users don't quite grasp that. That when you select a song, you don't just get one song. It's not or all the songs that have that name. You get the song and also links. Yeah. So by looking at this, you know that there's somehow a movie is related to this song. Yeah. Another problem with this that users have with this is that they're looking for a movie. So some users, what they do is they type in here keyword search, right? So again, they are influenced by Google, so they prefer to do keyword search. Okay? And then they get movie. Okay? But the problem is that most of the data in this knowledge graph calls it film. Movie is an American term, right? In the old days, it's called film. So most of the time, it's called film. So if I type movie, they don't get much information. Okay? However, if they click on this, I think they can still get some information. Sometimes they get this. It says a concert. Okay, this is not about movie. Okay, this one maybe. Okay, it says here accepted from the movie. Okay, so then this is about movie, and they do get some songs listed here. Okay, so this is another problem. Okay, this is a typical information retrieval problem, a mismatch between the user's keyword, like movie, okay, and the terms, control terms that are used in this knowledge graph. Okay, let me go on to the next one. Okay, maybe this one is more interesting. Zubir Said's wife. What is Zubir Said's wife's name? Okay, so Zubir Said has a wife. So what is the wife's name? Okay. Now, wife is a relationship, right? It's a relationship between two persons, husband and wife. Okay, it's a relationship. There are some users who think of wife as a person. No, wife is not a person, right? Wife is a relationship. But some users tend to think of wife as an entity. So wrong mental model. Okay, let's see what happens if you search for. Try to identify wife. Clear canvas. So if you enter people with links to Zubir Said, okay. Right, so wife is somewhere here, right? So this is a test of whether the user can filter out the information to find wife, because there are lots of people. Which one is besides wife? Okay, if your eyes are very keen, you'll see this, right? This one, it says here, Tamina Karyo, we call wife of Zubir's side. Okay, so you can find it this way as well. You can like have very sharp eyes. Okay, scan all this. Look around and scan. And some users do that. What they do is they click on this, click on this, click on this, click on this, and see whether it says anything. Okay, this is daughter, this wife. Okay. So again, this reflects the typical information retrieval mindset, which is not a knowledge graph, right? This is like looking at each record at a time. Yeah. Okay, if you want to find the relation or zoom into relation, one way is to go to this filter and then find that, oh, there's a spouse link, so you can uncheck everything and click on spouse. Okay, so now all the links are gone. You can see that the spouse is highlighted here. So this is a second way to find the link, but this is through the link. Okay, yeah, and some users did manage to find it that way. Another one is to reduce the, that the link is between persons, so you can reduce, you can uncheck all, and then find a person. Okay, but the problem is that Zubir site is a composer, so we use a, librarians, we use a more specific term, right? So if you don't have a composer, you just click on person, you might not find Zubir site because the composer is more specific. So this is, this is a usual information retrieval problem. So anyway, if I apply a filter, you can see that even, let me put all the links back. Oh, I see. All the links are back here. Okay. So by removing non-person nodes, it gives you a smaller number of nodes to browse through, right? And then you'll be able to find that, oh, okay. Tamina is wife of Zubir side. Okay. Let's see what happens if you type in wife here. That's what some users do. Type in wife, wife. Yeah, you do find it because I use the word wife in the label, right? In the title, yeah. So this suggests that, oh, I see that Yusuf, oh, I see, this is wife of another person. Okay, Yusuf Ishak is actually the first president of Singapore. So you can see that the labels that I use are more like a title. It's quite long. I try to put more information so that users can still search for this information. Okay, one last one maybe. Okay, this one. Find two persons who appear together in two photos. Okay, so I want two persons, they appear together in a photo and also in a second photo. Okay, all right, let's try to do this. Clear canvas, and let me get the photo links. Okay, these are all the photos. So I think I can immediately see that, see, this person here and this person appears together in the same photo. And you can turn out the photo. See? So by looking at the pattern here, you can tell that this person and this person appears in the same photo, see? Person shown. And they also appear together in the second photo. Yeah. So this is a test of whether they can look at the structure in the graph, okay, to answer a particular question. You can see another one here, right? Two persons appearing in one photo and then a second photo. Yeah. So I found that some users are able to do that, but there are other people who are clicking on this, like clicking on a photo and then read Rohana, Abdul Hamid, Tami, and then they are taking notes and then looking at another photo, you know, finding the names in each photo, to see whether they are, who are the people who are together in the same photo. So that reflects a traditional information retrieval mindset, right? Looking at each record at a time, to try to find similar ones, but not like looking at the relationships. Okay? Yeah, so I'm giving you some idea of the issues I find with users making use of this new type of interface that's more relational. So it takes a while for users to get used to looking at structural patterns. It's called topology, so patterns in terms of the graph. Yeah. Okay, I think I've taken up enough of your time. I hope you have found this interesting. The next step is, of course, to link this with text mining and generative AI to enrich these knowledge graphs. We're also looking to see what kind of data mining we can apply to this knowledge graph. Okay, this particular knowledge graph is, I think, too small to do data mining. I think for Sync Pioneers, after we have enriched it with 400, then we can do all sorts of social network analysis from 400 Singapore pioneers. Okay, this one I'm working with my colleague right now to see like what kind of new information we can derive from this. This one has quite a lot of data now. I forgot how many. Maybe has some 50,000 nodes inside this database. So we can already derive some interesting information from this knowledge graph. So this is like data mining or graph mining of a knowledge graph. Okay, right. Thank you very much. So if there's anything you want me to show, I'm happy to take questions and show you because all my code is on my computer. Okay, Dr. Tripathi, let me pass the session back to you.
Sir, it is really wonderful and wow. Because the session you have taken is really very informative, and you have shown the real scenario of development of the artificial intelligence, what we experience using the different AI tools. You have shown us that how this is developed. So really, it's a wonderful session. In my opinion, you have touched upon the generation of knowledge graph and the different visualization interfaces and retrieval method. What you have demonstrated, it has really been wonderful. Hats off to you, sir. And now, may I request the participants to please share your question, if any, so sir can take them and reply. And I also would like to request Dr. Achila Munigal, madam, to please uh, just.
Yeah, I'm here, Dr. Tripathi. It was a wonderful session. I just got to know in depth about knowledge graphs after your session, Professor. It was a really good session. I think I'll have more questions once I work on that and then get back to you, I think. Because although I had read about it a lot and I had not worked personally on it, so probably I'll have more questions when I start working on it. But I thoroughly enjoyed your session, and you took it step by step. So it was really very, very helpful. So probably I'll try it once. If I have a problem, I would like to get in touch with you if it's okay with you.
Yes, please do. I'm looking for, I'm actually developing this technology in order to pass it on to librarians. So I'm actually looking for collaborators, and I'm getting more and more collaborators. And yes, if my colleagues in librarians or like LIS researchers in India wants to develop something, I'm willing to work with Dr. Tripathi to organize some online workshops, to guide you through and share
Yes,
with you my code, to develop the
that
code
would
from
be
scratch is,
totally, truly wonderful. It will be if you can do that.
Sir, thank you.
And
Thank you very much. Thank
I
you very
also
much.
wanted to ask you one thing. When you make these knowledge graphs, for the free ones, I read somewhere some time back, although I'm not sure, they said most of these lack source attribution. Am I right?
sorry, can you repeat your question?
For the public knowledge graphs, I heard that there's lack of source attribution. So you cannot be sure of the information that is posted there, and it can also be edited by others.
Mm.
So
Yeah.
is this possible? Because I read somewhere a long time ago that
Mm. Mm.
it was written that Kannada, one of our Indian languages, they said it was not a good language or something. So there was a lot of hue and cry.
Mm.
So
Okay, yeah, yeah. Well,
it's
a
true.
knowledge graph, yeah, a knowledge graph is same as any uh, digital library. So it depends on the, the content developer. Uh, if I could show you, um, let me show you what we do, huh? Share
Yes,
screen. Okay, yeah,
because I wanted to see where you can attribute the
yeah,
source code.
right, yes. Uh, okay, okay. So I think, oh, is the sharing on? Okay. Let me show you this. Okay, this one. Okay, this one is by humanity one, and let me put in something else. Okay, a leaf. Yeah. Okay, and then what kind of leaf? A root leaf, a bud leaf, leaf. Uh, okay. All right. Now you can see that my colleague in history is very careful about attribution. And this is found here, see? So it says scientific name is this. And what is the attribution? It says, okay. So this is the source, The I here is
Okay.
information telling us the
Huh?
source. Yeah. And it also
Yes.
give the so-called provenance. That means which ancient book was this, was this herb mentioned? This is like almost the first mention, okay, in 1887 in the Qing dynasty. And then the source, see, and there are two sources. Yeah.
Okay.
And then they are found in these regions. And then the source again. Yeah. So the sources are also listed here, I think, as links. Is there a source? Okay, there's provenance. Oh, yeah. Okay. The source is given in the, okay, I think it's very interesting, maybe interesting for you. Um, if I type in provenance, see, it says
Mhm.
data source, So what is the source of
Oh,
this data? Yeah. So you can see that the source can be in the hyperlink, not the hyperlink, in the links, in the edge. Yeah,
yeah, yeah,
yeah,
yeah.
yeah. So I
Now that
think a
you've
knowledge
told
graph
me, I'll
gives you
check it out.
more possibilities for indicating the source, because the source can be stored in the links itself. And then
Correct.
once you get a source like this book, you can see like what other information is in this
Yes.
source. Yeah. Mm. However, of course, our other ones like this one, this is our own data, so it's our own source. Yeah. So we are not so careful about the source because it's from our own collection,
Yeah.
and the source is given by, yeah, by this, right? This is the actual photo that we have. Yeah.
Okay.
Okay. So I hope that partially answers your question. But yeah, source
Yes,
is, yeah,
it does. Now
important.
that you've told me, let me check it out. And if I have
Uh,
any doubts, I'd get back to you, Professor. Thank you so
Yeah,
much.
sure. Yeah,
Been most
thank you.
helpful.
You're most welcome. Yeah.
Yes, sir. If you allow me, can I just take some of the question? Few participants have a few questions. So, would you like to take them? Sir, please unmute yourself. You're not audible.
Okay, I see
Uh,
there's one question from Devanshu Saini. He
uh,
says, how can we use this knowledge graph analysis to improve reference services by integrating AI? Okay. Um, I think okay, I used to be a reference librarian, but I've not been a reference librarian in a long time. So I don't know now what sort of tools reference librarians use. I remember that in the old days, we used to have cards, for typical questions, like common questions. And in fact, I did try to develop a system like in the 80s, but in those days, the technology is not so advanced. So, so I think it's possible now to, yeah, you can, of course, use hyperlinks to link questions to answers, and so on. But you can also now, I mean, knowledge graph is kind of like a, hyperlink, right? It's like World Wide Web, the network links, but the links have labels, right? Like what kind of source or what kind of answer is it, and and so on. But maybe a more interesting one is how do you extract knowledge from the sources to populate this knowledge graph? So this is what I'll work on next year to try to get these, um, you know, uh, text sources and then extract um, facts, to populate this knowledge graph. So the short answer is I don't really know. It's something that we can work on. Yeah.
So another question from Madhuri Kumari. In the knowledge graph, why are you saying it is a social network in your definition? Could you
Yeah,
please
yeah, I know. Yes,
substantiate
yes.
with some example?
Yeah, yeah. First, I use social network to help the public understand. I think they understand social network better than an ontology. Because the typical definition of ontology is that it is what is a formalism. It is um, it is formalizing a specification in a particular domain and so on. And that kind of definition sounds very technical, and people find it hard to understand what it is. I mean, I have a whole lecture trying to understand, trying to explain that definition. But once I show them a social network, and I say that instead of persons, have people in it. I mean, no, you have concepts, you have resources. Then people understand that better. Now, I have a few papers that are under review, and in my papers, I try to make the distinction between ontology and knowledge graph. In the literature, people use them synonymously; they are the same. Okay? But I'm trying to make them different. I say that an ontology is focused on logic. There is a lot of emphasis on trying to make logically correct inferences. It has to be correct. The things you extract from it has to be very logical. So it's based, the focus is on logic, even though there's RDF triples and all that, but the preoccupation is to have a correct representation that gives you correct inferencing. Okay, but for me, a knowledge graph is more relaxed. It is not focused on logic. It's focused on the network, and maybe the social network. How social network meaning what are the related things, how they combine together to do something, and so on. So there's less, I think, emphasis on correct um, inferencing. So a lot depends on pattern, graph pattern matching. Yeah. So I see that more as a, and also with a knowledge graph, you can do a social network analysis. So that's it's not inferencing, but looking for patterns in the graph. Whereas in ontology, typically we don't look for patterns. That's not one of the focus of the ontology. So I do see a difference between knowledge graph, which is knowledge graph is more associated with a graph database, rather than an ontology. So I see more relaxed, more user-oriented focus for knowledge graph. So I use knowledge graph, as you notice, I use knowledge graph as an interface, to display related records, right? Not for inferencing, Yeah. Whereas ontology is more for inferencing.
Uh, Sir, I have one question. If you allow me, may I ask?
Yeah, please do. Yes.
Sir, there has been a lot more discussion about the different AI tools which are taking place in the different area like research writing, video creation, and many more. Means everywhere it is, means people are talking that AI will replace the human being. And but to some extent I do not agree based on my experience and my experiments. But how, means my question is that how do you see the future of AI in coming future?
Of course, the future of AI is very bright, but AI has always been overhyped. I remember when I was a young person. I'm now an old man. I'm going to retire, superannuated soon. In the 80s, there was like a lot of hype. Like AI is going to take. I mean, the same kind of hype that we see now, that is going to take over the world, and we had expert systems and all that, but it didn't, right? Yeah. Okay, but of course now things are much more advanced. AI is now doing a lot more. So to me, it's not so much whether AI is going to succeed. It definitely will become better and better. My concern is whether AI will take over human beings, right? Okay, will it take over human jobs? Yeah. So I'm also very concerned about that because I feel that our education system, certainly in Singapore and maybe in India, is focused on making our students become like AI, you know, like memorization, following templates, and so on. So I'm very concerned actually about our educate, how we are training our librarians, also training our students, because our education system is focused on learning how to do things, how to do step one, step two, step three. And that's what AI does. Yeah. So in my own teaching, I try to teach students to develop their human, you know, human thinking, to figure things out. So I think we need to focus, we need to understand more human thinking, okay, so that we can develop that more. And I told my students that if you develop your common sense, human thinking, AI cannot do common sense, right? All the AI researchers agree with that. Okay, common sense is only for human beings. Certainly, wisdom is not for AI, for human beings. So we need to develop, put more focus on developing our common sense thinking and common sense knowledge, and then we will be able to make use of AI properly. Okay? We will find innovative uses of AI, and AI will become better because AI by itself is not very good. It has to be combined with human beings, human work, to be uh, to be very usable, to be useful.
Correct, sir. One more question, sir. I will, because you have been taking session for more than 90 minutes, and it is going to be 2 hour. So the question is that from Ramaswamy K librarian, is it possible to develop such a knowledge graph for the entire library collection covering different disciplines?
Okay, to develop a knowledge graph for an entire library collection, you will definitely need AI. So there are people, yes, who are combining, looking to see how knowledge graph can be combined with AI. Complementing each other. There's one area called um, graph embedding. Looking for patterns in a graph. And so on. But if you are, of course, if right now I'm mostly doing human constructed knowledge graph, right? So that one, yeah, cannot be applied to the whole library. What I'm doing is focusing more on digital humanities. So humanities researchers have a lot of data, but it's still manageable. Yeah, so I help them to convert it and the examples I show you can all be considered digital humanities. So the data is much smaller than in a library. But for a library, that means lots of books and so on. I think that's a future kind of dream. Yeah.
Sir, one thing, do you think that AI will not affect the research work? Because people are getting more dependent on tools to for literature review and paraphrasing. Like this means they are depending slowly, means they are depending for everything related to research. So don't you think that it will affect the research work, real research work?
Uh, Research work covers many things, right? So for me, I think AI will be very useful in research in the same way as data mining. So in the old days, you have statistical analysis, and then you have data mining, and now you have generative or transformer-based AI. All this can be used to um, to help with research. So in my school, I actually teach data mining, and I try to show the students that in order to be very effective in data mining, you need a lot of common sense. You need to be curious. You need to ask questions. You don't just apply data mining and get a result and say, "Here's the result." No, you need to, think about what are the underlying explanation. So when you use all this AI technology, I think it is helpful to highlight certain possibilities, possible results. But then you still need to confirm the result, and you still need to find out the reasons for the results, which now AI cannot do. you know. So yeah, AI is a good tool for research, but researchers are still needed, to derive good results, valid results and usable results. So AI is still like data mining and like statistical analysis. They are tools, but you still need a lot of experience to be able to use it properly, and then get to validate the results and find the explanation and build theories, right? Theories. AI cannot build theories. It's a very human kind of thing. Yeah.
Yes, sir. Sir, really thankful to you for such a means exhaustive session. You have given lot many things to learn, experience, and also implement. So hope this
Yeah.
session will help the professionals to dig more about artificial intelligence and different tools, and especially the technology involved in it. So
Yeah,
means
but before we
this session.
go, maybe I see there's one interesting question by
Yes, sir.
Ankita Pattaracharya.
I will display on the screen.
Can polyglot medicine knowledge graph help biochemical activities of plant knowledge, and how AI help in plant taxonomy? Yeah, I think this is a good question, and actually this is what I'm working on now. Yeah, next week I will have some researchers from Thailand who are working in this pharmaceutical, uh, you know, uh, f- uh, analysis of plants. So you know that in Southeast Asia and India as well, there are lots of this herbal medicine, but the pharmacists are analyzing the active ingredients, the biochemical properties in this plant ingredients to see how they can help certain diseases, and so on. So they are coming to visit me to explore, to collaborate. Yeah. So in future, maybe you'll see that. Maybe next year I'll be able to show a knowledge graph that shows how it can be applied to manage and to these biochemical properties, pharmaceutical properties, and also to mine, to derive new knowledge from it. Yeah. Okay, so maybe it's time for all of us to go to bed. Thank you very
Okay, sir.
much,
Thank
Dr.
you.
Tripathi.
Sincere
Yeah, I
thanks
know
to
it's a
you.
lot of effort to organize this, and I really admire your passion for the profession to develop it, to grow it, to look for new directions uh, for the profession.
Sir, we are really thankful to you for sparing your valuable time and spending time to prepare and joining us and uh, throwing lights on the different aspects of AI. And now, may I request Dr. Gurpreet Singh to please offer vote of thanks to all the dignitaries and participants.
So, on the behalf of Librarian Guide and Dr. DP Tripathi and organizing team, I want to express my gratitude to Professor Christopher Koo for context-based presentation on knowledge graphs and visualization interfaces. Your insights into how libraries and librarians can leverage generative AI application in contemporary information architecture are truly invaluable. Today, libraries are on the verge of transformation era, no longer confined to merely offering access to information. They are poised to become dynamic hub of knowledge. This shift demands that libraries reevaluate and recalculate approach, moving towards the integration of data, ideas, tools, nodes, ultimately providing not just information but true knowledge. Once again, I thank you for shedding a critical evaluation on the role of libraries. Your presentation has provided us with profound understanding of path forward in modern information dissemination architecture. Thank you, sir.
Thank you, sir. Thank you, all the participants, for joining us. And tomorrow, once again, we will meet at 8 p.m. with another topic. And tomorrow, Dr. Nikesh Narayan will be talking about the different aspects of artificial intelligence. So, once again, thanks to all. Thanks to you, sir. And we will meet again soon. And I hope that I will see you in India soon. Thank you all. Thank you. Good night to all. Take care of. Stay happy. Stay blessed.